Okay, so Monday, remember that your short answer is going to include a section where you're going to have two shapes, and you're going to have to give me the surface area, the volume, and then the ratio. And then you're going to be asked to rank the shapes, which one would be fastest for diffusion, and then which one would be slowest. So here is a sample of all three possible shapes I could give you, and I've also included a little picture of the formula sheet section that would apply to this area. So let's start with the sphere. So for the sphere, we've got a radius of 0.2 centimeters. So if we come over here to get our surface area, here's our surface area for a sphere. It's 4 pi r squared. So 4 pi times 2 squared. You can leave pi. You don't actually have to plug in 3.14 for pi. You can if you want to, but you're kind of wasting your time because pi is going to end up canceling. So if you work that out, you're going to get 0.16 pi centimeters squared. It's very important you remember your units. For surface area, it's always going to be squared. So in this case, centimeters squared. And for volume, it's always going to be cubed. So centimeters cubed. If you leave out your units on the AP exam for a short answer, they're not going to give you credit at all. So it's very important that that's included. So that's our surface area. For our volume of a sphere, there's the formula right here. 4/3 pi r to the third. So this is going to be 4/3 pi times 0.2 to the third. And if you work that out properly, I rounded this to 0.0107 pi centimeters to the third. And then to get the ratio, you are literally going to divide your surface area, so 0.16 divided pi divided by 0.0107 pi, and notice how pi cancels. So that's why I was saying you don't actually need to calculate it, and you're going to get a ratio of 15, or basically what that would mean is 15 to 1, that you have 15 times the surface area compared to your volume. Now, just a reminder, you may not remember this from the notes, but there is a shortcut. 3 over the radius will give you the ratio in one step. So if you can remember that formula, you can double check your answer. So 3 over 0.2 gives me 15. And so I know that I did it right. That way I can go back. If you get a different answer, you're going to know that either your surface area or your volume is incorrect. If you round a little differently, you might have gotten a slightly different answer, which is fine. You might get 14.5. You might get 13.9. It really depends on how you round it. And I'm not concerned about that. All right, we can't do the rank yet until we have our other two shapes done. So our second shape is our cube. So you're going to notice that there is no formula for surface area. I'm sorry, there is one for surface area. There's no formula for volume of a cube. For surface area of a cube, it's right here. 6 times the length of one side squared. So that's going to be 6 times 0.2 squared. And that's going to give us 0.24 centimeters squared. Again, don't forget your units. For volume of a cube, that's the one that you're not going to find it here. But the volume of a cube is technically the same as the volume of a rectangular solid. That's length times width times height. And in this case, since all three sides have the same length, that's technically going to be a side to the third, or length times width times height, which is going to be 0.2 times 0.2 times 0.2. And that's going to give you 0.008 centimeters to the third, or you might have gotten it in scientific notation, 8 times 10 to the negative 3. It's the same thing. Now we're going to divide this out, so 0.24 over 0.008, and our ratio is 30, or basically 30 to 1. So here's our first ratio was 15. Our second ratio was 30. So far, our cube is definitely going to be better. It's going to have a better ratio than our sphere. All right, our last one is a rectangular solid. Now, for this one, notice at the bottom here, the formula for surface area of a rectangular solid is terrible. The formula they provide is very ambiguous, and a lot of people have trouble with it. So I had told you, my suggestion was to memorize a different formula. For surface area of a rectangular solid, do 2 times length times width, plus length times height, plus width times height. Multiply those out and then divide, multiply by 2. it doesn't matter what you make, the length, the width, and the height. As long as you end up multiplying all three numbers by each other, it makes no difference. So if I plug this in, it's going to look like this. It's going to be 2 times, and then it's going to be 0.2 times 0.5 plus 0.2 times 0.3 plus 0.5 times 0.3. And you'll notice, so I've basically multiplied all of my numbers times each other. And then don't forget at the end to multiply by 2, and you get 0.62 centimeters squared. And then volume's easy. Volume is here. Length times width times height. It's the one right here, second one. And so if I do length times width times height, it's literally going to be 0.2 times 0.5 times 0.3. And that's going to give you 0.03 centimeters to the third. And then 0.62 over 0.03 is going to give you my ratio, which comes out to 20.7, or 20.7 to 1. Oh, and going back, I forgot to mention, there is a shortcut on the cube as well. If you want to check your answer on the cube, just like the sphere had a shortcut, the shortcut on the cube is 6 over the length of one side. And if I do 6 over 0.2, I actually get my ratio of 30. So if you can remember the shortcut, 6 over the length of a side, you would be able to check your work and see if you had done it right. It's not going to allow you to solve the problem any faster because on the test, I'm requiring you to show me your surface area and your volume. And you wouldn't have to do that possibly on the AP exam. If all they asked for is the ratio, you could use that shortcut to get it quickly. All right, now I'm going to rank them. So the highest is the best. So this would be my best cell. This would be my second best. This would be my third. All right, so there's a walkthrough of how to do surface area to volume ratios and how to determine which cell would be the most efficient. All right, the second thing that's on your short answer is metric conversions. There's going to be 3 of them. So here are 3 practice ones. The most important thing that you need to know is how to use these metric prefixes, because unfortunately, this is the only piece of information that they're providing you with on the AP exam on the formula sheet. So you need to understand what information you're being given here. So the factor, I'm actually going to scratch out factor. This is the number of meters is equal to 1 of whatever the prefix is. In other words, let's say I want the conversion to go for gigameters. 1 gigameter here, one of these, is equal to 1 times 10 to the 9th meters. That would be my conversion factor to go from gigameters to meters. Because again, the 1 of the prefix is equal to this number of meters. And that's the thing you have to understand, that that exponent is always going to go with meters, and the 1 is always going to go with your prefix. So let me show you this in action. So here's our first one. So we're going from micrometers to kilometers. So I can't go directly from micrometers to kilometers given the information that they're providing me with. But I can get from micrometers to meters. So I can find out how much 1 micrometer is equal to in meters. And I can also get from meters to kilometers. So my 2 units are micrometers and kilometers. I'm going to come over to my chart and see how many meters each one of these is. So I see here 1 micrometer is 1 times 10 to the negative 6 meters. And 1 kilometer here is 1 times 10 to the 3rd meters. Again, notice how my exponents are always going with my meters, and it's always 1 of my prefix. And that's because of the way that they're providing the information for the AP exam. It's not the ideal situation, honestly, but because of the information they're giving you, I'm just showing you how can you solve it with the information they're giving you. All right, so now we've got our conversion factors. So now you're going to do dimensional analysis. So 3.2 times 10 to the 6 micrometers. I want to cancel micro. So I find the conversion factor that has micro in it, which is my first one here. So my conversion factor is 1 micrometer is 1 times 10 to the negative 6 meters. Micro will cancel, and now I've got meters. My second step, I need to get rid of meters, and now I want to get to kilometers. So I want meters on the bottom this time, and I see 1 times 10 to the 3rd meters is 1 kilometer. Now in your calculator, what you would literally plug in would be 3.2 times 10 to the 6 times 1 times 10 to the negative 6 equals, get an answer, then divide that by 1 times 10 to the third. Be really careful if you're not using the E button on your calculator. If you're not familiar with that button, then it's very important when you plug this in your calculator that you use parentheses. Because if you don't, your calculator may do a different order of operations than what you want it to do. Because it's going to do exponents differently than multiplying and dividing. All right, so if you multiply that out, you multiply and then divide, your final answer is going to be 3.2 times 10 to the negative 3, or 0.0032. Either of these would be acceptable. And don't forget your units, we were converting to kilometers. All right, our second one, we're going from centimeters to meters. So remember, the factor is already meters. So we don't need two steps in this problem. If meters is one of the two things here, then you're only going to need one step. So I look up centi, and here's my conversion factor. So I see that 1 centimeter is 1 times 10 to the negative 2 meters. And now 5.9 centimeters times 1 centimeter is 1 times 10 to the negative 2 meters. And you're basically going to multiply, and your answer is going to be 0.059 meters. So that's our second one. And then for our last one, I'll bring it down here to the bottom. Okay, so for our last one, we're going from giga to milli. Giga, milli. So we need two conversions. We need our gigameter to meter conversion, and then we need our meter to millimeter conversion. So coming to my table here, I see giga here. So I see that 1 gigameter is 1 times 10 to the 9th meters. And our other conversion that we need is millimeters. I see 1 millimeter is 1 times 10 to the negative 3 meters. And now we can use our dimensional analysis. So again, 8.1 times 10 to the negative 3 gigameters times our conversion factor. We want giga on the bottom. 1 times 10 to the 9th meters on the top. Giga will cancel. Now we want to get rid of meters. So 1 times 10 to the negative 3 meters on the bottom is 1 millimeter on the top. Meters will cancel. And in your calculator, you would do 8.1 times 10 to the negative 3 times 1 times 10 to the 9th equals whatever, divided by 1 times 10 to the negative 3. And I'm running out of space, but your answer this time is going to be 8.1 times 10 to the 9th millimeters. Your calculator may not put this in scientific notation, but you really need to. I really don't want you to give me this answer. 8, 1, 1, 2, 3, 4, 5, 6, 7, 8. This is ridiculous. You should convert that to scientific notation. There is a button on your calculator that'll do that, but if you don't know where that is, you can see me Monday morning. I can show you. But you really should take really big and really small numbers. If your calculator doesn't put them in scientific notation, you really should. All right. So that is a walkthrough of how to do these problems. Remember, again, on this third one, you need to put parentheses in your calculator unless you're using the E button. If you know how to use the E button, that's going to save you a lot of time and energy, and you won't need parentheses. But if you've never used that, it may not be something that you want to try to do for the first time when it's test time. If you run into any other problems or questions, you can always shoot me an email. But hopefully this tutorial straightens out any misconceptions you might have.